Hi, welcome to the Olympiad Geometry Club. Let's continue our study on geometry triad. Today we're going to talk about the Steiner-Lehmus theorem generalization. Here I listed two theorems. Actually, it has a third one, but it's very lengthy and I will put it in another video. So the theorem 1, in triangle ABC, P is a point on the angle bisector AD other than point D. Let's just draw the figure. We have triangle ABC here, and we know that angle bisector AD and P is another point on the AD. BP, CP meet AC, AB on EF. BP, CP meet AC, AB on EF, respectively. If BE equals to CF, so we know that BE equals to CF, then AB equals to AC. So we know that AD is an angle bisector, P is a point on AD, and we know BE equals to CF. We want to prove that AB equals to AC. So first, we know that we can just assume if AB is larger than AC, and then we can eventually get a result that our conclusion would be conflicted to our assumption. Then we know that AB equals to AC, right? Okay, so let's just assume AB larger than AC. Then we know that angle B is less than angle C. Right, angle B is less than angle C. And because AD is an angle bisector, which means angle B plus half of angle A plus half of angle A plus angle C equals to 180 degrees. And angle B is less than angle C. So we know that angle B plus half of angle A should be less than 90 degrees, which means angle ADB is larger than angle ADC, right? So angle ADB is an obtuse angle, and angle ADC is an acute angle. So then we can use the cosine law to calculate for the BP and PC, right? So BP squared equals to BD squared plus DP squared minus 2BDDP cosine angle BDP. And for the PC, we know that PC squared equals to CD squared plus DP squared minus 2DP DC cosine angle CDP. Because AB is larger than AC and AB to AD equals to AC to CD, so we know that BD is larger than DC. So BD is larger than DC. And also because angle BDP is an obtuse angle, which means the cosine angle BDP is a negative number. That is saying, if we use the absolute value here, this would be a plus sign, right? But for this one, we can use absolute value here, it's the same thing. Then we know that BP is larger than PC. Okay, BP is larger than PC, which means angle PCB is larger than angle PBC, right? Let me just explain what am I doing here. It relates to methodology that I think I already talked about this many times, but I still receive lots of emails and message ask about how to find a way or find a breakpoint of a certain solution. The method is like this. You never think about a solution. Like, you never think about how to solve the problem. You just try to find as much information as possible you can from the problem set. For this problem, it's the same thing here. We already know that AB larger than AC. We already know that AD is an angle bisector, and we know that BE equals to CF. And we know that we can assume AB larger than AC. Now we want to find something, right? What we can find is that we want to know about because we are trying to prove that AB equals to AC, and we assumed that AB is larger than AC, which means that eventually we want to find the relationship between AB and AC, something like that. Basically, we want to find a relationship of the length of two sides, right? Which means any segment comparison here might be useful. So here, that's what I'm now doing. I'm trying to find as much information as possible from the problem set. Okay, now we get that BP is larger than PC. What else we can get? We know that the angle BAD equals to angle DAC. So we can have this one, AP2 sine angle ABP equals to, in the triangle ABP, okay? AP to sine angle ABP equals to BP to sine angle A. And in the triangle APC, we know that AP to sine angle ACP equals to PC to sine angle A. Right? Because BP is larger than PC, so BP to sine angle, sorry, not sine angle A, sine half of angle A, right? So because BP is larger than PC, so BP to sine half of angle A is larger than BP to sine half of angle A here. So we know that this one is valid here. Now we know that sine angle ABP is smaller than sine angle ACP. And obviously that angle ABP and angle ACP are acute angles, so we know that angle ABP is less than angle ACP. Right? Angle ABP is less than angle ACP. And if you recall the method we used in the last video for the simplest way to prove the equal sides, right? The second method I used in the last video. You recognize this one, and we know that B equals to CF, so you can remind yourself that, oh, now I know this question. We can simply do an auxiliary line here because ABP is less than ACP. So we can find a line here that make angle PCM equals to angle PBA. Right? We let angle PCM equals to angle PBA. And because of this, let's do this here. Set this point as N. So we know that BN is less than BE, which equals to CF, right? So BN is less than CF. BN is less than CF. And in the triangle, if we look at the triangle MBN and the triangle MCF, the angle BMN equals to angle CMF. And because we already set angle MBP equals to angle MCF, we know that these two triangles are similar, which means this triangle and this triangle are similar, and BN is less than CF. So we know that BM is less than CM, which means angle CBM is larger than angle MCB. And what is angle CBM? The angle CBM is angle CBP plus angle MBP. And angle MCB is angle PCB plus angle MCF. But we know that angle PCB is larger than angle PBC. So this angle PCB is larger than angle PBC. And also we know that we already set the angle MBP, this angle, equals to angle MCF. So we should have this sign. Then you know that these two are conflict, right? These two conclusions are conflict, which means AB equals to AC. Okay, if you want to make it looks like easier to understand, you can just set AB larger or equals to AC, and then eventually you got the result AB should be less or equal to AC, and then you get the answer that AB equals to AC. But I like to use just larger than AC because it makes a stronger assumption and eventually makes the confliction looks more straightforward. Okay, it doesn't matter. So that's our first theorem. And let's look at the second theorem. In triangle ABC, okay, I'll just draw the figure here. In triangle ABC, let DE be the points on side ACAB, respectively. BDCE split the angle ABC and ACB to 1 to K ratio. Okay, so here, let's say it's K beta, 1 beta, it doesn't matter. Here is K beta, and for here, this one is K gamma, this one is gamma, this one is K gamma, right? And we know that BD equals to CE, we want to prove that AB equals to AC. So it's obvious, right? Because we can simply assume that beta is larger than gamma, then we can make another line here similar to this problem, and then we can prove that this one is eventually larger than this one, makes a confliction that gamma is larger than beta, right? And then the assumption is not valid, which means that beta equals to gamma. Okay, so for this problem, I would say the simplest method is a way that we already introduced in the last video. So if you feel confused about it, please review that video. And this is first two theorem of the generalization of Steiner-Lehmus theorem. And we will see a very complex one and a very strong one in the following video. I hope you like this video, and if you think this is helpful, please click the like button, comment, share, and subscribe to the channel. Thank you.